So this week for sure, all classes on Tuesday are moved to Thursday because Tuesday and Wednesday is the Atlas testing. So tomorrow, if you're Atlas testing, then you'll be Atlas testing. Otherwise, there's no classes tomorrow. They're moved to Thursday. So Monday and Thursday this week for our classes. So whether that's good or bad or otherwise. So, all right. And we do have a new student in our class. Homer has joined us. So he'll be with us the rest of the semester here. But let's get folks in here. Let's see. Last week was the exam. So hopefully you guys got that. Let's see how we did on getting that turned in. If I look at the grade book. There's some exams. Let's see. Most of you, I haven't graded it if you've turned it in. There's a couple of questions I have to grade. But I see, let's see, missing 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 of you have not turned in last week's test, which means over 20 of you have. So that's good. But if you have not turned in last week's test, you need to get that done. So we'll be moving on from that. So we are starting a new unit today. Starting a new unit. We're going to be in Unit 7 with arithmetic sequences and series. So you will want to have your pencil and paper out for some notes because there are some critical formulas you need. That makes this real easy. If you don't know these formulas that we're gonna have today, then you'll be struggling all the way through and like, man, I don't know how to get this. What am I trying to do? Well, the formulas make it real easy. So you definitely want that in your notes. Remember, you can use your notes on assignments, tests, semester final, anything. So, all right, how we doing on getting folks in here? We got 75% of the class pretty much in here. But let me get on the right screen for one thing. I'm not even on the right screen before I put this up. Let me get this up here today. We got a lot to cover, a lot of notes going. I've already got my camera open over there for notes. So we'll get this up the screen and see what all we're looking at today. Okie dokie. Looking in Buzz in our algebra class. Let's go to the grade screen as usual. We always start on the grade screen. We'll go down here. We see that, yes, everything should be in through Module 6. 6.05, the rational equations exam was last week. So hopefully you've got all that turned in. Here's what we have left this semester. Arithmetic sequences and series is due this Sunday. Then we're going to try to do geometric sequences and series. Both those are separate assignments, but we're going to put them together and do them both next week. And then we'll get into graphing the week after that. Let's look at 7.01 this week. Back on the activity screen. Let's see, I don't know why I had the matrix unit open. Let's open folder module 7 here. And we'll look at this first lesson. Then we'll look at the assignment. But let's look at the lesson first. 6 pages. That's not too bad. Not too bad. All right. Oh, we got, I'm going to open up the chat because we got some class participation stuff right off the bat on this. In the following activity, you will be shown a list of numbers separated by commas. This is known as a sequence. Sequence is a list of numbers separated by commas. Your objective is to identify the pattern and determine the next numbers or terms in the list. So let me make this a little larger where it's easier to see on the screen. Perfect. All right, what are the next 3 numbers in this sequence? We've got 8, 23, 38, and 53. Camden's got the next one, the next 2. All right, 3. All right. So look at those. You think those folks are right? You think there's a better answer? This is just a simple pattern, right? We've got 8, 23, 38, 53. If you're not sure what's going on here, subtract going backwards. What's 53 minus 38? What's 38 minus 23? What's 23 minus 8? Well, every one of those, there's a 15 difference. So it's starting at 8 and adding 15 each time, which you guys have nailed this. It is 68, 83, 98. That would be the next three. Excellent. Let's see, there's 4 of these. All right, how you doing this one? You got -5, -7, -9, -11. What are the next 3 terms? And a lot more you need to be chiming in here.
But again, there's a low grade. I just have to go back and do that. Yes, Reagan?
All right, not having a big problem with that. Anyone else? This one's a lot simpler. It's just subtracting 2 every time, right? -5, -7. So those are all the odd numbers, and they're all negative. So we just keep going with the odd numbers. -13, -15, -17. All right, let's see if it gets a little trickier. Oh, I knew it was going to get trickier. How did I know that? Must not be the first time I've seen this. 3, 1.75, 0.5, -0.75. Okay. Seeing a variety of answers here, by the way. Let's look at the very next one. This is going from 3 to 1.75. So it's subtracted 1.25. 1.75 to 0.5, subtracted 1.25. So if we continue that pattern and we have -0.75, the next one should be -2. And a lot of you got that pretty quickly on there. -2. Then if we subtract another 1.25, and we subtract another 1.25. All right. Great job. One more to go here. 2.5 or 2.5, 3.25, 3.25, 4. What's the next numbers in the sequence? 2.5, 3.25, and 4. There you go. All right. So going from 2.5 to 3.25, it added 0.75. Going from 3.25 to 4, it added 0.75. Think of like money if that helps you think of the fractions. $2.50, 3.25, $4. So the next will be 4.75. You get another 75 cents, 5.5, 6.25. Yeah, you guys got this. You're not going to have any problem with this arithmetic stuff, right? Notice the terms within each sequence are separated by a comma, right? That's how we separate terms in a sequence of numbers, by commas. So after completing this lesson, you'll be able to answer these questions. How can an expression or process be determined for an arithmetic sequence? What functions combine to create an explicit formula? What possible restrictions exist on the domain and range of arithmetic sequences? And how can an expression process be determined for an arithmetic series? So an arithmetic sequence is a list of numbers that we call them terms, the first term, the second term, the third term, the fourth term, which they share a common difference. So we're going to look at some more sequences. Some of these are sequences. Others are just sequences of numbers. Some of them are arithmetic. Some of them are just sequences. So we got to separate which one's arithmetic, which one's not. So let's just say yes or no. We'll make this easy. Is this an arithmetic sequence? Yes or no? which means are we adding the same number every time? Like on those others, we added 0.75 every time. We added 0.75, added 0.75. This one, oh, I see no's flooding the feed of responses here. 1, 2, 4, 7, 11. Well, there's definitely a pattern, but it adds 1, then it adds 2, then it adds 3, then it adds 4. But that's not the same every time. That is not arithmetic. Okay, yes or no? Is this an arithmetic sequence? Is it adding the exact same number every time? You're like, oh, that's some weird numbers, Mr. Brock. I don't think I've ever seen a sequence like that. No, you probably haven't. That's really weird. So it starts at 3. The next number in the sequence is negative 147. The next number, negative 297, and negative 447. Got 2 people jumped out there and said yes. Oh, now 3. Yes, it actually is. It's adding or subtracting. It's adding a negative 150 each time. Each one, if you subtract another 150, 3, add negative 150, add negative 150, add negative 150. This is an arithmetic sequence. Okay, this, yes or no, is this an arithmetic sequence? 10, 8, 12, 10, 14, oh, all the even numbers. Oh, but those are all, I see 8, 10, 12, they're all 2s. Yeah, this one adds a negative 2, and then adds a positive 4, then adds a negative 2, then adds a positive 4. There is a sequence going on here. There is some pattern, but it's not arithmetic. This is a non-arithmetic sequence. How about 4, 14, 24, 34? Oh, quick with that one, right? Oh, sure. Yeah, we're just adding 10 every time. That one's pretty good. So 4, 14, 24, 34, it is arithmetic. Common difference of 10. 1, 2, 4, that's not arithmetic. I mean, there's a pattern, but it's not the same every time. There's the negative 150 common difference. And then this one where it's going negative 2 plus 4, negative 2 plus 4. Good job with all that. All right, let's shrink this back down. And let's go to page, that is that. Page 2. All right, now here's the thing. A sequence can appear in different forms. We were looking at sequence like this, right? Just giving it numbers with a comma in between them to say, here's the first term, here's the second term, here's the third term, here's the fourth term. But we could see it in a table where it says the first term is 3, the second term is 6, the third term is 9, the fourth term is 12. And if we can have it in a table, we can take those points from the table and put them on a graph. The first term is 3, the second term is 6, the third term is 9, fourth. These are all the exact same sequence. 3, 6, 9, 12. 3, 6, 9, 12. 3, 6, 9, 12. Different ways to show the same thing. Now notice with this, we don't connect those with a line, because nothing exists between the first term and the second term. The first term is 3, the second term is 6. There's no 4 or 5 or 3.8 or 5.162. There's nothing between those. So we just use the dots, not a line. And that's what they're saying. You'll notice there's not continuous line through the points because the sequence is discrete. We call this discrete. A set of data is discrete if it is finite or there's spaces right in between there, because it's only these exact points, not every point in between there. So it's continuous if you can connect it with a line. The connected with a line means every single point in between those would exist, all the decimals and all of that. Okay, we're going to use 2 different words for this sequence, for this whole unit: recursive and explicit. Recursive and explicit. Let's get to figuring out what these mean. A recursive process requires the use of the previous term in a sequence. Like if we have the sequence that says add 2 to get the next number, like if I want to know what the 6th number is, I just take the 5th number and I add 2 according to this sequence. And that will give me the 6th. And if I want to know the 7th, I just take the 6th one and I add 2. And I take that one and add 2 and I get the next one. So this could be listed as a sub n equals a sub n minus 1 plus 2. And we'll get into looking at these formulas. But n would be the number you want, right? A sub n. Like if I want the 9th term, it would be 9. A sub 9 would be the 9th term. N minus 1 would be 8. So that just means I take the 8th term and I add 2. And that would give me the 9th term. Right, so we can continue doing that. If the first term is 3, the second term would be the first term plus 2, which means it'd be 3 plus 2, which the second term would be 5. The third term means I got to take a sub 3 minus 1, which is a sub 2. Take the second term, add 2, add 5 plus 2, I get 7. So 3, 5, 7, 9. And we can continue on. The word recursive contains the prefix re, which means again. We just keep doing this again and again and again and again to get all of the terms of the sequence. So let's compare that to explicit. This allows you to calculate any term directly. Like if I want to know what the 13th term is, with recursive, I have to find out the 12th term. And now, in order to know the 12th term, I have to know the 11th. And to know the 11th, I got to know the 10th. I got to work back. I got to have somewhere to start and just keep finding each term. With explicit, I can jump straight to the one. If I want to know the 13th, I can use the formula and say, this is the 13th. I don't even know what the 12th is, but this is the 13th. So we will learn to do that. We don't have to know the term before it. So we could find the 45th term of this sequence, 2, 9, 16, without finding all the 41 terms in between there. So let's look at deriving the explicit formula. So they're going to do it on here. We'll do it in our notes. So let's see. So this is 2, 9, 16. So they said, if we want to know a formula for this, 2, 9, 16, ... And when we look at these formula type things, 2, 9, 16, the common difference, we call that D. D is common difference. And in this case, what is the difference? Well, each time we add 7. So our common difference is 7. That's the common difference between each term. So if we make a table, like they were showing on there, and we want to know the first term. First term. Well, the first term is just 2. Right? We have to know what the first term is. It's just 2. But if we want the second term, we take the first term, which the first term is called a sub 1. The second term would be a sub 2, and so on. A sub 3, a sub 4. So those would be the term numbers going through here. This would be the third term, fourth term. We just take, for the second term, we take a sub 1, which is the first term, and we add the common difference. Common difference was 7. So we just take the first term and add 7, and that would give us 9 as the second term, which we do that, 2, 9, 16. But we're going to keep going here. So for the third term, we take the, well, we could take the second term and add 7. Or if we want to take it back to the base, What I really did is I took the first term and I added 7 twice. Because when the first time I added 7, it gave me the second term. The next time I add another 7, I get the third term. It gives me 16. So really what I did here is a sub 1 plus 7 times 2, right? Times 2. Which means if I want the fourth term, I can take the first term, add 7 3 times, which is 21. 21 plus 2, 23. And I can continue that on. Or if I want the fifth term, if I start with the first one, I would do the common difference 4 times and get 30, because that's 28 plus 2. Now, I want you to notice something here. Let me replace this with 7 times 2, since that's what we did. Multiplied the common difference times 2. Do you see a relationship each time we're finding a term? Even with that one, we're just doing 7. Doing 7 one time, right? Just doing 7 one time there. Do you see a relationship between the term we're looking for, a sub 5, and how many common differences we're putting on there? So if we just want to know the nth term, a sub n, like this could be 40, it could be 21, it could be 37, whichever term, we can take the first term and the common difference 1 less. Look, when we went the fourth term, we took the common difference 3 times. With the second term, we took the common difference once. We took the fifth term, we did the common difference 4 times. Whatever n is, whichever term we're looking for, we just multiplied the common difference times n minus 1. N was 5. 5 minus 1 is 4. N was 3. 3 minus 1 is 2. Here's a formula that will give us any term. A1 plus the common difference times n minus 1. All we have to do is know what the common difference is and know what the first term is. If we know what the first term is, the common difference, we can find any term we want. So let's find the 45th term on here. I want to know what the 45th term of this sequence is. This says I can take the first term, which is 2 plus d, the d was 7, n minus 1. What's n? N is 45, so 45 minus 1, which is 44. If I take 7 times 44 and add it to 2, that will tell me what the 45th term is. So let me pull up our calculator. And we're going to take 2 plus 7 times 44. 310 is the 45th term of this sequence. If anybody wants to work that out for us, and just keep going until you get to 45 and tell us if we're correct or not. No, this is correct. I guarantee you. Because eventually we start with the first number and we add 7 to it 44 times. If we take the first number and add 7 44 times, that's the 45th number, which is 310. So, wonderful formula to have in your notes for an arithmetic series. And this is the explicit formula. Explicit formula, which means we can jump explicitly to the 45th term. Now, the other one they already talked about, the recursive. If we want to know the 45th term, like we want to know the 45th term with the other formula, we had to know what the 44th term was and add 7. right? Because that's what it says. If we know the term before, you just keep adding 7. So this was a sub n minus 1 plus d. This is the recursive formula, which we might use this formula if we want to know like the 5th term. Oh, well, I can find the 4th term and the 5th term real easy. But if I want to know the 45th term, I probably don't want to use this. I want to jump to this one up here. Connect those. This is the recursive formula. So that's the 2 big formulas that you want to have in your notes for arithmetic sequences. Either finding the next one based on the one before it, or just knowing the first term and the difference. You have to know the difference in both of them. But this one uses the first term. This one uses the term right before that term. So this one we couldn't calculate. We'd have to go back and find the 44th term, which means if we want to find the 44th term, we got to know the 43rd term and add 7. Which means we got to know the 32nd term and add 7. Which means we got to know the 31st. Yeah, I can keep going. But that gets cut off. So, yeah, 45, 44, 43, 42. This one, we can just jump straight to 45th term. That's a much better pencil. So they're going to work through it. To get the second term, you just do 1 times the common difference and add it to the first term. To get the third term, we do the common difference twice, 2 times the common difference added to the first term of 2. For the 4th term, we take the first term of 2 and 3 times the 7 on there, which is what we were talking about. And it says, what pattern, where does the 2 come from? Well, 2 was the first term, right? When we had this sequence up here, there's 2, 9, 16. 2 is the first term. Where's the 7 come from? 7 was the common difference. It goes from 2 to 9 to 16. That tells us that the common difference is 7. How's the factor before the 7? I wrote it after the 7, but this is determined by 1 less than the term number. 4th term uses 3. 3rd term uses 2. So the factor for the common difference comes to the position of the term minus 1. So what's the 5th term? 30, which we had done on our chart. Says, let's see if a formula can be found by taking this 5th term and working backwards. Okay, we've got this in our notes already, but let's see how they do that in this video that they have right here.
The 5th term of the arithmetic sequence is 30. 30 can be rewritten as 2 plus 28. 2 represents the first term in the sequence, which is indicated as a sub 1. 28 is the difference between 30 and 2. 28 can be written as 4 times 7, where 7 represents the common difference between each term of the sequence. 4 is the result of 28 divided by 7. Use the variable d to indicate the common difference. 4 is the same as 5 minus 1. 5 represents the 5th term in the sequence, and 1 is the difference between 5 and 4. The variable n is used to represent the position of the term in the sequence.
All right, so they came up with the same formula. They just put the D after the parentheses. I like putting the D before the parentheses because you have to distribute it when you're actually calculating if you were actually doing that. But since this is n minus 1, we don't have to distribute. We just take 1 from the n. But this is the exact same formula. Whether you put the D before the parentheses or the D after the parentheses, either way it says multiply D times what's in the parentheses. So write it whichever way you prefer, but I just prefer to put the D in front of the parentheses. So here they have the 2 formulas, the recursive and explicit equations. recursive. That's the one where a sub n is found by looking at a sub n minus 1 and adding the common difference. To find the 45th, we look at the 44th and add the common difference. And here's the other one that we have. A sub n equals the first term plus the common difference times n minus 1. Oh, look, they reversed it here. Their video has it the other way around. It has n minus 1 of d. This one has it the way I have it written down, put d in front. All right, let's go to page 3. So it talks about how this is really all from a combination of functions, right? One part of the function is a sub 1. A sub 1 is just a constant. It never changes. Whatever the first term of your sequence is, that's always the first term of your sequence, right? Just because I'm looking for the 11th term, the first term is still exactly the same. If I'm looking for the 19th term, the first term is exactly the same. What changes is the n minus 1. If I'm looking for the 14th term, n minus 1 is 13. And then when I multiply it by d, I get a different number. If I'm looking for the 8th term, n minus 1 is 7. So it really says that this is a combination of a constant plus a variable expression. Okay, it's a constant plus a variable. A sub 1 never changes. This will change because n will be different every time. Right, the d is constant, but the n makes it a variable. And when we add these two formulas back together, we get the whole formula. A sub 1 plus d times n minus 1. So let's talk about the domain and range of a sequence. Now, the domain is all of the x values. The x values. So I want to go back. I want to go back to when we had the table on the first page, where we saw, or is that, I guess it was page 2, had the sequence first as just a sequence, 2, 4, 6, 8. We could do it as numbers, or we can do it as a table. Remember, table, it had which term number it is as the x, and the value as the y. 1 is 2, 2 is 4, 3 is 6, 4 is 8. The first term is 2, the second term is 4, the third term is 6, fourth term is 8. So the domain, if you're thinking of the x's, that's the term number. The term number. So if I say, what's the first term in your sequence? You could tell me, oh, the first term was 2. But I would never be able to ask you, what is the 1.6th term of your sequence? And you're like, Mr. Brock, did you hit your head really hard? Because I don't have a 1.6th term. I have a first term and I have a second term. There's no terms in between there. This one's first, this one's second. There is no 1.6. Yeah, I probably hit my head too hard because you're right. There is not a 1.6th term. So if we're thinking about the domain, and the domain is the term numbers, that tells us that the domain is only going to be integers, nothing with a decimal. And it also tells us, okay, you told me your first term, you told me your second term. What's your negative third term? Come on, Mr. Brock. I don't have a negative third term. The first term is the first term. That's why it's called first. It's the first term. There's not another one. Not another one before that. It's first. So there's no negative numbers in our domain. Right. No negative numbers. How about 0? What's your 0th term? No, there's not a 0th term. So the domain of an arithmetic sequence of numbers is integers greater than or equal to 1. My domain is 1, 2, 3, 4, 5, 6, so on, so on, so on, so on. It's only integers greater than or equal to 1 because the domain is the x's and the x's is the term number. But what about the range? That's what the number is in the sequence. What is the first number? Well, it was 2, and then it was a 9, and it was a 16. So the range can be different. In that case, the range was 2, 9, 16, 23, as that sequence went on. But we looked at a lot of sequences that some of them were negative 0.5, negative 1.25, negative 2, negative. Oh, so the range is not limited to only positive integers. The range can be anything. It just depends on the sequence. The domain never changes. It's always 1, 2, 3, 4, 5. Integers greater than or equal to 1. Always, 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 always. So anytime you're ever asked, what's the domain of an arithmetic sequence? Oh, it's just integers that are 1 or larger. 1, 2, 3, 4, 5. But the range could be anything. Depends on your sequence of numbers. It could be decimals. It could be negatives. It could be 0. It could be, it could have all of that. So that's what that boils down to. So this says the terms start at 1. So when we're talking about the domain, which is all the x's, the domain for arithmetic sequences is restricted to all integers greater than or equal to 1. Just like we said. All integers greater than or equal to 1. 1, 2, 3, 4, 5, 6, 7. Keep going. The natural numbers. The range can be any number because we saw ranges that went, 147 and, kept getting huge numbers real big. We had negative numbers. We had decimal numbers. So it does not have the same restrictions. All right, let's look at some examples. Once you have the arithmetic sequence formula in your skill set or in your notes, working with sequences will be a breeze. So they want us to find the 46th term, where this is the first term and this is the 12th term. Oh, this is a pretty good one. This is a pretty good one. So we're going to write this one down. They want to know the 46th. A sub 1 is negative 22. This will be good to have in our notes because it's not straightforward. What do you mean it's not straightforward? Well, what's the common difference? We have to know the common difference in both formulas, right? Both formulas. Doesn't matter whether we use this formula or this formula, which with the 46th, we want to use this one. Right? We want to jump straight to it. I don't want to find the 45th and the 44th, and the 43rd, and the 42nd. But I have to know the common difference. What's the common difference? This is the first term. This is the 12th term. It's not the second term. 12th term. Well, we got to do a little work to figure out the common difference. But fortunately, if we look at this, you give it a little thought. If I gave you some time to think about it, a lot of you would come up with this. But we're limited on time, so I'm going to kind of bump it forward. We can go over here, and we can use this formula with these two numbers. Let's just use this formula and substitute what we know. Forget the 46th. I'm just looking at the first and the 12th. If I said, okay, I know the 12th term. The 12th term is 77. So if I did A sub 12, which is 77, A sub 12 would equal A sub 1 plus the common difference times 12 minus 1.
Okay.
Right? If I know the 12th.
Right.
So I know A sub 12 is 77. I know the first term is negative 22. I don't know what D is, but I'm trying to figure it out.
Yeah, okay.
And what is 12 minus 1?
It says we need 2 players.
12 minus 1 is 11.
Player A will score a point.
Look, I have an equation that just has one unknown variable in it. So let's solve this for D. I need to get D by itself. Well, I've got a negative 22, so let's add 22 to both sides. So this is 99. This is canceled out, negative 22 plus 22. Let's arrange this the other way, 11D.
Okay,
D
so
times 11 or 11 times D, doesn't matter.
to roll 10 times.
I'm solving for D. I've got 11 times D.
After each player has multiplier by 10 seconds. So you either roll 10
D
or 20.
equals 99 divided by 11.
So the points tell me how many times.
Our
you
common
made.
difference
Yeah.
is 9. Wonderful. Now I can
No,
find
you
the
do,
46th
you do,
term.
but I don't
I
see
want the
that's one
46th
thing
term.
others.
I want to know what
So there should have been a winner.
A46 is.
That's okay. You can redo it again. It doesn't take very long.
Well, it's A1, which is negative 22,
No, you roll a 20.
plus
But
D.
for some reason you stopped that.
Oh, I know what D is now. I figured it out. Times N minus 1. N is 46. N minus 1 is 45. Oh, look, no variables at all. This is just a calculator work now. Let's pull up the calculator. Close it.
Okay, roll the dice. Let me see it. And then explain.
Okay.
Get your dice out and
We'll put the calculator over here. Let's take, well, first let's just multiply this. 9 times 45. So this is negative 22 plus 405. What is negative 22 plus 405? Okay, 22 negative plus 405. 383. The 46th term of this sequence is 383. If we start negative 22 and we add 9 every single time, at the 46th term is 383.
Okay, yeah.
Let's see what they got. It says find D. That's the first thing you have to do, find D, because we didn't know that. So we substituted in. 77 equals negative 22 plus 12 minus 1D. Since we know the 12th term,
Yes.
we found that D equals 9. So that's the same work we did on the paper.
And
Then we use that to find the 46th
so
term.
my next question to you, Aria,
And it's 383, just like we thought. The 46th term of the arithmetic sequence is 383. Great job.
1 through 6.
We nailed it.
I tell you when I say, hey, what are the
All right, there's a second problem right here. Example 2. So we need all the examples we can get in here.
That makes me.
There is a library containing triangular bookshelves where each consecutive shelf has 4 more books than the shelf above it. If the top shelf holds 7 books, how many on the 11th shelf? Okay. Library containing triangular bookshelves. Each consecutive shelf has 4 more than the shelf above it. And the top shelf has 7. That means on the 11th. I think they phrased that wrong. If it's 4 more than the shelf above it.
No, like you're playing a game against another person. Like
7 would have to be. Oh, I guess it's triangular upside down. No, it would be upside down. 11th shelf. Let's use what they've got.
No, you're okay because
They're gonna work us through it down here.
This is your work.
First, define each variable in the automatic sequence formula. What is the first term? Well, first term must be 7. That's the only shelf they gave it.
It's telling you, it's asking you.
Oh, 4 more books than the shelf above it. So it gets bigger as it goes down. The top shelf is 7. Okay, I see what they're saying.
So on that
There's 7
top
in the
row,
top shelf.
on that top
And then the shelf below that will have
that is
11.
one dice.
And the shelf below that will have 15. It just keeps going on. And so they're counting down from the top, down to
So
the
say
11th.
you count 2 dice.
They're just counting the other
That's
direction.
it. And then like the game. The game's
All right, the second question is,
off.
what is the common difference? The common difference. It said each shelf contains 4 more. 4 more.
You're welcome.
All right. 4 more would be plus 4, right? It'd be a common difference of 4. Positive 4 every time. Great. What is the value of n? Well, it's asking us about the 11th shelf. So n must be 11. Right? And then it finally says, now you can apply the arithmetic sequence. How many books are on the 11th shelf? Okay, well, we'll have to work on that one. So if we've got a sub 1 equals 7, our common difference is 4, and we want to know the 11th. we take the first one plus d times n minus 1. 4 times n minus 1. 7 plus 4 times 10. 4 times 10 is 40. Add 7. There should be 47 books on the 11th shelf. We got? That's it. Just working through the formula. So just identifying what D is, what A sub 1 is, what the N is that you're looking for. Here's more examples. If you want to look at some more examples on arithmetic sequences, I won't work this one because you've got it right here. It gives you all the steps. But find the 29th term of this sequence, 11, 8, 5, 2. So you can try that one on your paper and then check here to see if you're right. They give you the answers. Let's go to page 4 because we need to look at arithmetic series. A series. Now, there's a little bit of a difference. With an arithmetic series, they're not separated by commas. There's a plus sign in between. Arithmetic series are added, which means if I want to know the series, like if my sequence is 1, 2, 3, 4, 5, but my series would be 1 plus 2 plus 3 plus 4 plus 5. So let's look. I want to make this big again. Drag and drop each list of numbers to either series or a sequence. 4 plus 14 plus 24 plus 34. We saw this sequence. Remember 4, 14, 24, 34. They had commas in between them. That's what a sequence is. A sequence is a list of numbers. This is actually a series. A series, you take that exact same sequence and you add them together. So is this a series or a sequence then? It looks familiar. Put that in the chat. Put that in the chat. Is that a series or a sequence? And I gave you an example of a series right there. Series, you add them all together. Sequence, you separate them by commas. Yeah, really all you have to look for is there a plus sign or is there a comma? If there's a comma, it's a sequence. How about this one? 1, 2, 3, 4, 5. I was just talking about that sequence. Yeah, it's got commas. How about this one? 10 plus 8 plus 6 plus 4 plus 2 plus 0. Yeah, anytime there's plus symbols, that's a series. All right, great job. We have a video down here as well. So let me start down. Now you're able to distinguish between a sequence and a series. Let's discover how to find the total of a series without having to add them all up, which is, this isn't hard. 4 plus 14 plus 24 plus 34. That's not hard. We can all do that. Probably do this one in your head, right? But if I said, here is the sequence of numbers, what is the total of the first 23 terms? Now we're like, oh my goodness, Mr. Brock, I got to figure out 23 terms and then add them all together. Well, let's see. We might not have to do all of that. Let's see what this shows. No sound on this one. Okay, let's go step by step. What did they do? They had this series of numbers, 4 plus 1 plus -2 plus -5 plus -8 plus 11. And they've taken the first number and the last number and added them together. Look at that. 4 plus -11 is -7. All right. Now they're going to take the second number and the next to the last number. So the second one from this direction and the second one from the end, and add those together. And it's -7. And then they take the next one, the third from each end, -2 plus -5, and add those together. We may be onto something here. We add the first and last one, the next two, they all add up to the same number. That's a big hint on what we're doing here. Notice that each pair of terms adds up to the same number, -7. So we could just multiply that times 3. We're not going to add those together, -7 plus -7. Oh, we're just going to take it times 3 because we're high school kids, right? That's the way we think. Oh, that's -7 times 3. It must be -21. Well, that would be what those add up to then. Because to get these -7s, we added these together. We added all those together. We got -7 3 times. So those must all add up to -21. There may be something there. Oh, let's look at this real quick. Let me make this larger. We need to understand the vocabulary if we're going to be successful with all this. We need to understand the vocabulary. So the last term in a finite sequence, the first term in a sequence, the common difference between the terms, and the number of terms in a finite sequence. So with these 4 choices up here, A sub n, A1, n, and D, which one of those would be the last term in a finite sequence? Would that be an, A1, n, or D? What do you think? I'm going to the last term in a finite sequence. All right, Ethan said that'd be an, A sub n, Vivian, Liza, Cameron. All right, you guys got it. It would be A sub n. Because if we want to know the last term in a finite sequence, like we have 9 terms, A sub n would be A sub 9. So that's right. How about the first term in a sequence? What do we call that? What's the vocabulary we use for the first term? Yeah, great. A sub 1 is the first term. Common difference. How do we note that? Yeah, D for difference. That one's kind of a gimme. D for difference. And N is the number of terms. How many terms are in the sequence? 23. N would be 23. The 23rd term would be A sub 23. N is the number of terms. All right, great. All right, so in this, it says using some or all of these variables, write a mathematical expression allow you to find the value of 7 from the arithmetic series. So let's do this one on paper because we need to have the formula anyway. So let's look at arithmetic series. I'm going to write that down before I switch over on the screen. So they were using this arithmetic series. And he took, whoever did the video there, took the first and last terms, and they added those together. It said that is -7. And then they took the next 2 terms. 1 plus -8. And again, got -7. And then we took the next terms, -2 plus -5. And once again, we got a -7. So in an arithmetic series, and with an arithmetic series, you use an S. An S sub, let's see, for this one, S sub 6, there's 6 terms. S sub 6, 1, 2, 3, 4, 5, 6 terms. S means sum. Think of sum. Sum is when you add everything together, you get a sum. So we use an S instead of an A. We're talking about a series sum. And if we took the first term and add it to the last term, and then we multiply it by 3. First plus last would be -7. -21 is what they add to. Is that right? 4 plus 1 is 5. 5 plus negative 2 is 3. 3 plus negative 5 is negative 2. Negative 2 plus negative 8 is negative 10. And negative 10 plus negative 11 is negative 21. So that is correct. You can check it just by adding. So how does this give us a formula? So if we have S sub n, which would be 6 in this case, how did we get that? How did we get 3? Oh, it looks like there's a relationship right there that we can use. We'll see if that works every time. If there's 6 terms, that means there's 3 pairs. 3 pairs. Because there's 6 terms. We took them by pairs. We added them together. So if we took n and divided it by 2, that would give us the number of pairs. Right? That's how many pairs of numbers are in 6. There's 3. And then we took 4, which is the first term, and 11, which is the last term. A sub 1 plus A sub n. Oh, I think we have a formula. Arithmetic series. The sum be the number of terms divided by 2 times the first term added to the last term. The first term added to the last term. A wonderful way to find. This would be an explicit. We were looking at recursive or explicit because I don't have to know the term before the last term. I just go straight to it. The sum, let's take the first one and last one. I like that. Let's see. So they said, write an expression allowing to find the value of 7 from this series, which they went A sub 1 plus A sub n, right? The first term plus the last term. That would give you that negative 7. And it's being multiplied by 3. Well, there's 6 terms, so we divide that in half. There's 6 terms and divide it by 2, since we're pairing them up together. That'll give you how many pairs exist. So page 5 tells us, they're going to use a video for the big reveal that we've already figured out on paper. That's all right. We'll take their video and see what it says. See if this one has sound.
The sum of the 6 terms of the arithmetic sequence is negative 21. Negative 21 can be rewritten as 3 times negative 7. 3 represents the number of pairs in the arithmetic series, and negative 7 is the result of negative 21 divided by 3. The 3 pairs in the arithmetic series can be written as 6 divided by 2, where 6 represents the number of terms in the series. Negative 7 can be written as 4 plus negative 11. 4 represents the first term of the series, and negative 11 represents the last number of the series.
There you go. That's what we came up with. N divided by 2 times the first plus the last number combined together there. Let's take that back down. So that gives us the formula. S sub n equals n divided by 2, first plus the last. Handy formula. In the arithmetic series formula, the variable s sub n represents the sum. That's what I said. The s represents the sum of the series. So you find that by applying the formula. 6 divided by 2, 4 minus 11. 6 divided by 2 times negative 7. 3 times negative 7, and it's negative 21. And what are they doing here? Oh, okay. They found the other formula they can use here in a little different way. So they said, okay, let's say, we'll go ahead and build this other formula. The other formula says, all right, maybe we don't know the last term. If we don't know the last term, we can still start this. A sub 1 plus, I don't know the last term. Well, it just so happened that I have a formula over here to find the last term. All right, this formula right here tells me how to get to a sub n. A1 plus dn minus 1. A1 plus dn minus 1. So this we took from our sequence formulas, or series formulas, sorry. Sequence formulas, yeah. Why do I make sequence series on there? Oh, this is a sequence. Yeah, I was getting ahead of myself. For the next sequence, and we're just substituting it in right here, right? Substitute that. Now we can simplify it. S sub n equals n divided by 2. Look, we've got a sub 1 plus a sub 1. So this is twice a sub 1. Multiply it times 2 plus dn minus 1. So this formula will also find the sum of the series if you don't know the last term. If you know the last term, use this. If you don't, use a sub 1 and the common difference. This one, you don't even have to know the common difference. So if you know the first and last term, you use this one. If you know the first term and the common difference, you use this one. First and last. First and the common difference. So depending on which one you need, those are the two formulas we use for an arithmetic series. And to give you a moment if you're writing that down. It's also going to be here in our notes on this page. N divided by 2, 2a1 plus n minus 1d. Again, you can put the d in front, the parentheses are behind it. It doesn't matter. But they said, let's use this to find that second formula. So we could say as n divided by 2 is still 6 divided by 2. The first term is 4, so we're taking 2 times 4. The common difference is negative 3. 4, 1, negative 2. So negative 3. N minus 1 is 5. So take 5 times negative 3 is negative 15. 2 times 4 is 8. 8 minus 15 is the negative 7 times 3. We still get the same sum. So you can use either formula depending on what information you have. Okay, here's some practice. And here's the lesson summary. Lesson summary gives all formulas. Arithmetic sequence formula that's the same formula this is. These are the same. Okay, these are the same. So the only difference is they put the D after the parentheses or they put the D in front of the parentheses. But they're exactly equal to each other. Those are the same formula. So these are the recursive and explicit formulas to find term numbers, terms. Series is when we're adding them all together, and they gave us those two formulas down there. So if you have those in your notes, those 4 formulas in your notes, you should be able to do all of the problems. All the problems, those 4 formulas. Let's look at some examples here. The sum, if it says sum, that tells us which formulas we need. So I need an arithmetic series. 44th term of a series with the first term is negative 9. And the last term is 120. Okay. So I said find the sum of the 44 terms. The first term is negative 9, and the last term, this is the last term, but since they said we're adding up 44 terms, we don't say 44, 120. So we have first and last. That means we can use this formula. The sum of 44 terms is 44 divided by 2 multiplied times -9 plus 120. Okay, just plug those into our formula. So that's 22. What about 2? -9 plus 120 is 111. It's just 9 less than 120. Let's grab the calculator back up here. 42 times 111. So if we add 44 terms together, it'll equal 2,442. Let's check. 2,442. That is one of the choices. That's it. They show how to go through the, that's exact same formula we used, exact same numbers, and there are 4 problems there. Right, let's look at the second activity. What is the first term? Oh, I'm going to like this one. Yeah, they're going to make us work for this one. They want to know the first term. What is a sub 1? Question mark. There's 14 terms, and the 14th term is -12, and the sum is 42. So this uses the same formula. But we just have to plug in what we know, and we don't know a sub 1. We know everything else, though. We know what the sum is. The sum is 42, so we're going to say 42 equals, because that's what S sub n is, n minus 2. Do we know n? Yes, we know there's 14 terms. 14 divided by 2. We do not know the first term. That's what they are asking us. A sub 1 plus, we know the last term. Well, so let's do some math. 42 equals 7. A sub 1 minus 12. Because we add a negative, it's just a sub 1 minus 12. We need to distribute here. Oh, we don't have to distribute here. We can divide both sides by 7. Since this is being multiplied by 7, we can divide it by 7. So 6 equals a sub 1 minus 12. Add 12 to both sides. The first term is 18. So this is a sequence that's going down. It starts at 18, it ends up at -12 after 14 terms. And it adds up to be 42. Let's see if that's right. A sub 1 equals 18. Correct. All right, and there are 4 problems here as well. Just figure out what do you have, what information did they give you, and then figure out from that, which formula do I use? Use this one or that one? Or do I need just to know a term number? What's the 9th term? Well, that would be this one or this one, depending on what information you got. So those are the 4 formulas you want to have. You can do basically all of this if you know those 4 formulas. Let's go. Page 6 just says, read the lesson, read the examples, practice problems on your own paper. Make sure you can answer those questions they gave us on page 1. There's those 4 questions. And let's go look at the assignment. So remember, the lesson is first. The assignment is the same name right underneath it. Just doesn't say lesson. What do we have? We have 1, 2, 3, 4, 5 questions. Multiple choice. 5 questions this week. Find the 35th term. Here's the first term. There's the 18th term. Like, wait a minute, Mr. Brock. We did one of those. They gave us the first term and the 12th term, and they asked for the 46th. This is the same thing. You have to go over here and figure out what the common difference is. Then come back and find the term they want. But you plug in what you know and see, which one did we use? We used the explicit formula. Use the explicit formula, plug in what you know, find the common difference over here. That's exactly what this first problem is doing. It's giving you the first one and the 18th, and want you to find the 35th. So use these with that formula to find the common difference, then plug it in with the common difference to get the 35th term. Same type of problem. Find the 27th term, where here's the first and 17th. These are identical type problems. The windows of an office building arranged on each floor is 6 fewer than the floor below it. So this is like the bookshelf problem that we did. The ground floor is 52. How many is on the 8th floor? This is 6 fewer. So your common difference is -6. -6. It's getting smaller. Given these functions, 11, f of n equals 11, and g of n equals -2n minus 1, this is the constant part. This is the variable part. It says combine them and then solve for the 31st term. If this is the first term, that's the common difference. So how do you combine these two? Is this the formula that uses minus, or is this the formula that uses plus? Find the 31st term, n equals 31. And here is a table. First term 40, second term 47, third term 54. Create the explicit formula and list any restrictions to the domain. What is the domain limited to? Is it n is greater than or equal to 40 or n is greater than or equal to 1? You should be able to eliminate two of these answers and then figure out which formula. Is it 40 plus 7 n minus 1 or 40 minus 7 n minus 1? Look at that, figure out what the common difference is. All right, this ain't bad this week. Arithmetic, it's just adding numbers on a sequence of numbers. 3, 6, 9, 12. So you can do this. May not take you very long. You probably have those next 5 questions done before your 4th hour, if you have a 4th hour. But I'm going to wrap it up right here. It's 2 o'clock. You've got 20 minutes left that you can have of this class period to do that. And if you've got any questions, email me. Or remember, Tuesday and Wednesday this week, Atlas testing. So we won't have class on Wednesday. And Friday is a virtual lab day if you're coming up in person. All right, guys, have a great week. Get this knocked out. Start Unit 7 on a big, strong note right here. Getting it turned in. And we'll see you next time.